Okay, we take a look into detail the voltage divider circuit in high frequency response. Okay, I convert the circuit into AC equivalent, AC circuit here, AC equivalent circuit for the voltage divider. So the DC is changed to ground, and then okay, the RE now is eliminated because there is a bypass here. So we remove the RE, and then we can see the CBE and CE now. Okay, this CBE is connected like this. Okay, it will go to ground, and also with the CCE, it will connect it to ground. So the circuit become like this. Okay, you see, now we have CBE here and CCE. Okay, because no RE anymore, and this circuit is only a wires and connected to the ground. So I can split the CBE and CCE become like this. Can you see? There is no more connection between C and between B and E terminal, because we have this wire. Okay, now CBE is I draw CBEs like this and CCE like this. Okay, this is the full AC circuit, and however you can see the CPC is still like this. Okay, I cannot split this CBC, okay, because it connect with the B and C terminal. That's why we need the another formula, okay, to solve, okay, this calculation later. So for this, because of this, we will use the Miller effect capacitance. Okay, so I will explain here. This Miller effect capacitance, when we change the BJT into RE model, so we will get beta RE and beta IB here. But still, the CBC connected like this. The connection of the CBC is still like this, and this looks like this model. Okay, this model, it is an inverting amplifier with the feedback capacitor. So if you compare this figure with this one, so it actually the same configuration, like the amplifier is here and we have the feedback capacitor like this. Okay, I can see it like this, CBC, and this is your amplifier. Okay, so there is another formula with the Miller effect capacitance. So this formula you can divide for the input part and the output part. Okay, I already make the formula. So based on the high frequency AC equivalent circuit in previous slide, we can see that interelectrode capacitance that connects between between base, okay, and base and emitter, okay, between base and emitter, CBE, is already included in the AC circuit by using Miller effect capacitance equation. Okay, so what is Miller effect capacitance? Okay, what is Miller effect capacitance? This is the Miller effect capacitance, right? So Miller effect capacitance will look on the parasitic capacitance that connect between terminal like this. Okay. The inter-electrode capacitor can be described as a feedback capacitor between input and output for this one. Okay, this is for the input. Okay, then the Miller effect input capacitance equation is Cm in, Cmi or Cm in equal to 1 minus voltage gain multiplied with Cf. Okay, is like this. Now the input part of the network can be replaced by the Miller input effect capacitance equivalent network. So it becomes like this. Means that this capacitor now become like this. So the formula is this one. So you can remember this formula for Cm in. Okay. And now for the output side, okay, the derivation for the equation is from this figure. Then we get Cm out or CMO equal to 1 minus 1 over AV multiplied with CF. Okay. Then, okay, in this case, okay, remember in this case, what is CF? For the circuit that I use for this example, CF equal to CBC. Okay, remember this. CF equal to CBC. Okay. So this also CBC. Okay, now we take a look for the overall circuit in AC equivalent network with the capacitance. Okay, so we have C in here. Okay, C in actually the total we have CW in, CB in, and CM in. Means that now the CM in no longer exists at this part. Okay, sorry, the CBC is not here anymore because we already calculate the CM in. So actually this CBC, okay, I remove this CBC, it's removed already, and now the CM in is here. Okay, like this. CM in, and you have parallel CW in, and you have parallel CBE. Okay, this is all capacitor, and it connect with the R1 and R2. Okay, like this. Okay, so C in means a total of the capacitor at the input, and C out the total capacitance at the output. Same goes here. There is a CM out. Okay, CM out here, and we have CCE, and we have CW out. Okay,